TC cable is designed for specific applications, and direct burial is not one of them. The use of TC cable for direct burial is a violation of electrical codes. It is important to consult the National Electrical Code, or NEC, and local electrical codes for proper installation methods and approved wiring types for underground applications. TC cable, or tray cable, is primarily intended for use in cable trays, raceways, and for some direct burial applications when specifically permitted and marked for such use. However, typical TC cable is not designed to withstand the harsh conditions associated with direct burial, such as moisture, soil acidity, and mechanical stress. Direct burial cables are specifically constructed with features like a robust outer jacket that is resistant to moisture, chemicals, and physical damage. They are also designed to resist corrosion and degradation when in direct contact with soil. The NEC specifies approved wiring methods for underground installations in Section 300.5. This section outlines the requirements for burial depth, protection from physical damage, and the types of cables and conduits that are permitted for direct burial. Cables such as underground feeder or UF cable, and cables in rigid metal conduit or RMC, or rigid polyvinyl chloride conduit or PVC, are commonly used for direct burial applications because they meet the necessary requirements for protection and durability. When inspecting electrical installations, it is crucial to verify that the wiring methods used comply with the NEC and any local amendments. In the case of the campsite wiring, if the TC cable is installed directly in the earth, even if it is sleeved with PVC at each end, it is a violation unless the cable is specifically listed and marked for direct burial use. The PVC sleeving provides some protection from physical damage at the point where the cable enters and exits the ground, but it does not address the cable's overall suitability for direct burial. The proper approach would be to use a cable that is listed for direct burial, such as UF cable, or to install the TC cable inside a conduit approved for direct burial, such as RMC or PVC. If using conduit, the conduit must be buried at the appropriate depth as specified by the NEC Table 300.5. The depth depends on the voltage, the type of wiring method, and whether the installation is under a building, under concrete, or in a specific location like a residential driveway. For example, for a residential branch circuit rated at 120 volts or 240 volts, direct buried cables need to be buried at least 12 inches deep. If rigid metal conduit or intermediate metal conduit is used, the minimum burial depth is typically 6 inches in residential areas. PVC conduit also typically requires a 12-inch burial depth. These depths are intended to protect the cables and conduits from physical damage due to digging, vehicular traffic, and other activities. In addition to burial depth, the NEC also requires that underground cables be protected from physical damage where they emerge from the ground. This can be achieved by using conduit, enclosures, or other approved methods. The point where the cable enters the ground is a common location for damage, so providing adequate protection is crucial for maintaining the safety and reliability of the electrical system. The NEC also addresses the issue of corrosion in underground installations. Section 300.6 requires that metal raceways, cable armor, and other metal components be protected from corrosion when installed in direct contact with the earth. This can be achieved by using materials that are inherently corrosion resistant, such as PVC conduit, or by applying a suitable coating or wrapping to the metal components. When using metal conduit for direct burial, it is important to ensure that all joints and fittings are properly sealed to prevent moisture from entering the conduit. Moisture can lead to corrosion and electrical faults. The NEC also provides guidelines for the separation of underground electrical cables from other underground utilities, such as gas pipes and water pipes. Section 300.5c requires that underground cables be installed at least 12 inches away from other underground utilities, unless the cables are protected by a barrier or other approved method. This separation is intended to prevent damage to the electrical cables from excavation activities and to minimize the risk of electrical hazards. In summary, when installing electrical wiring underground, it is essential to use wiring methods and materials that are approved for direct burial. TC cable is generally not suitable for direct burial unless it is specifically listed and marked for that purpose. Always consult the NEC and local electrical codes for detailed requirements and guidance on proper installation practices. Using the correct wiring methods and materials will help ensure the safety and reliability of the electrical system and prevent code violations. Also, remember to inspect the labeling of the cable to verify that it is listed and marked for the intended application. The listing and marking provide assurance that the cable has been tested and evaluated by a recognized testing laboratory and that it meets the applicable safety standards. If the cable is not listed and marked for direct burial, it should not be used for that purpose. If you are unsure about the proper wiring methods for a particular application, consult with a qualified electrical contractor or electrical inspector. They can provide guidance on the applicable codes and standards and help ensure that the installation is safe and compliant. The consequences of using improper wiring methods can be severe, including electrical shocks, fires, and equipment damage. It is always best to err on the side of caution and follow the NEC and local electrical codes. Always ensure that the electrical installation is properly grounded. Grounding provides a path for fault current to flow back to the source, which helps to trip the circuit breaker or fuse and de-energize the circuit. Proper grounding is essential for preventing electrical shocks and minimizing the risk of electrical hazards. It is also important to protect underground cables from physical damage during and after installation. Backfilling trenches with sand or other suitable material can help to cushion the cables and prevent them from being damaged by rocks or other sharp objects. Warning tape can also be installed above the cables to alert excavators to their presence. Regular inspections of underground electrical systems are important for identifying potential problems before they become serious. Look for signs of damage, such as cracked or broken conduits, exposed wires, and water accumulation. If you find any problems, have them repaired by a qualified electrical contractor as soon as possible. Remember that electrical codes and standards are constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest requirements and to follow them carefully. This will help ensure that your electrical installations are safe, reliable, and compliant with the law. Consider also the environmental factors at the campsite. Soil conditions can vary widely, and some soils are more corrosive than others. If the soil is particularly acidic or alkaline, it may be necessary to take extra precautions to protect underground cables from corrosion. This could include using a more corrosion-resistant type of cable or conduit, or applying a protective coating to the cable or conduit. The presence of moisture in the soil can also accelerate corrosion. In areas with high water tables or frequent flooding, it may be necessary to use submersible cables or conduits to protect the wiring from water damage. Consider the potential for physical damage from animals. Rodents and other animals can chew on underground cables, causing damage that can lead to electrical faults. To protect against animal damage, use cables that are designed to be rodent resistant or install the cables in a conduit that is resistant to animal intrusion. Before starting any excavation work, always call your local one-call center to have underground utilities located. This will help prevent damage to underground cables and other utilities, and it will also help ensure your safety. Digging without knowing the location of underground utilities can be extremely dangerous. When working with electrical wiring, always follow safe work practices. To energize the circuit before working on it, and use appropriate personal protective equipment such as rubber gloves and safety glasses. Never work on electrical wiring when you are wet or standing in water. If you are not comfortable working with electrical wiring, hire a qualified electrical contractor to do the work for you. Working with electricity can be dangerous, and it is important to take the necessary precautions to protect yourself and others. It is also important to properly document your electrical installations. Keep records of the wiring methods used, the cable types, the burial depths, and any other relevant information. This information can be helpful for future maintenance and repairs, and it can also be useful for verifying compliance with electrical codes.